Hello students, and welcome to Form 1 Physics. The topic for today is measurement. We are going to proceed from where we stopped last time. And to confirm that we're in class, please students send us an SMS to 21450, writing your name and the locations to confirm that we're in class, we're running physics with us. So in our last lessons, we introduced the topic of measurement. And for now, they're going to go head on and go to the measuring instrument. And as I said, measurings involves now comparing the unknown quantity with a known unknown quantity. That is the standard international unit. The choice of the measuring instrument, as I said in our previous lessons, it depends on the quantity to be measured and the accuracy that is desired by the observer. Those two determine now the instrument that we use. And we are going to start by measurement of length. Measurement of length. We said length, we define length as a distance between 2 points. I have point A here and I have point B there. And these 2 points, they can be as close together or they can be very far. The point A can be Nairobi and the point B can be Nakuru. The point A can be here, literally here and there. So the choice of the instrument again is defined by the quantity, because it would be very unusual, as I said, for me to measure the distance from here to Nakuru using a meter ruler. It would be unusual. So if the quantity and the accuracy desired determines now the measuring instrument that we use. For shorter distances, we normally use we normally have meter ruler or meter rule. We normally have tape measures. So these are the two instruments that we normally use for measuring length. We have, for the tape measure, we have various types of tape measures. We have the surveyors tape measure. We have the other ones that is used by the carpenter. We have the carpenter's tape measure used by the carpenters. And we have the other ones, which is what we call the tailor's tape measure. Tailor's tape measure. So these are instruments that we use for measuring the meter rule or the meter ruler. And someone might ask what's the difference between the meter rule and the meter ruler. Let me give a difference, the distinctions. We have the meter rule and we have the meter ruler. The meter rule, its marking or its graduations start at the very edge of the ruler. There's no space left, there's no allowance left. That's for the meter rule. And we have half meter rule and we have the meter rule itself. We have the one that's actually half, that's from 0 to 50 centimeters. Then we have now the full one, the full meter rule. And I've said for the meter rule, the marking start at the very edge. There's no allowance left. That's in case this thing was to chip off, it will actually go with some markings. Then for the meter ruler, we see it's a bit wide, and then the markings start. It's a bit indented. We have 0 there, maybe 1, 2, and so on. We can see we have some allowance here, and just in case actually it's cut off, it is still safe. Meter rule and meter ruler. So I have said we normally use those two instruments for measuring length: the tape measure and the meter rule or meter ruler. And I have said for the tape measure, we have 3 types of the measure: the surveyors, the carpenters, and the tailor's tape measure. So how do we normally use the meter rule? To use the meter rule, the first thing that you do is, one, is that you actually must place it. I'm sorry I didn't come with one. You actually place the meter rule in contact with the object we are measuring. So this is the desk. So I have to put my meter rule here. So that's the block of wood I'm measuring. So I have placed my meter rule in contact with what I'm measuring, and then you ensure that the edges are in line like that. So my 0 is here, 1, 2, 3, 1, 2, like that. This could be 3, and this is maybe 4, and so on. Then we say the edges are, we observe that the edges are in line completely, and it's like it's suspended in air. It's actually lying on the what we are measuring. Then from there, we say the third thing to note is that you must place your eye perpendicularly. If the ridge is here, let me mark this clearly. If the ridge is here, you place your eye perpendicularly, like that, like above it. Because if you lead at an angle, like that, or like that, we introduce an error that we call parallax error. You end up giving the wrong thing. Because if you look like this one here, suppose this was to proceed, let me show it clearly. This is 4, and you read like this, then you have another one here. This line may not coincide here. This one will actually be far ahead because this movement of the observer, therefore the movement of the object also moves. This apparent movement of the observer resulting to this coming backward. And therefore, if suppose this was 4.2, this appeared to move backward, you get now maybe 4.3 or 4.4. Because we are saying the parallax error, which is defined as the movement, the error introduced because the apparent movement of the object due to the movement of the observer. So if you place your eye here, so you might come and give this as even 3.9 because the object is backward. So you introduce that error that we are calling the parallax error. So we are saying that when you're using the meter rule, you place it in contact with the object we're measuring, and you ensure that the edges are in line, and then you place your eye directly, you give that reading. Because if you don't do that, you introduce parallax error. So the accuracy of the meter rule is numbered at 1 decimal place. Let me magnify this one. So this is 0 is here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose we are supposed to give the reading, that reading there. Right in the middle, we can give it as, we have 5 here, this is 6, 7, and 8, then 9, 10. So 6, 7, 8. But it has not reached, it's not at 8 exactly, it is not at 9 exactly. So we can actually approximate it to be 8.5. So I'm doing this to show you that the accuracy of the meter rule, it cannot be 2 decimal places. We say that it's 8.51 or 8.52 is not possible. So the accuracy of the meter rule is accurate to 1 decimal place. And even this 1 decimal place is also approximated, that we assume that this one is right in between 8 and 9. So we assume it's the middle. So even this value here is also approximated. So the meter rule, as you see later as we advance in physics, in topic of measurement, is not really very accurate. It gives an approximate value. It's not that 100% accurate, because we see even approximating this number here. So as we go to Form 2 and do measurement 2, we have other instruments like what we call the vernier caliper, micrometer, screw gauge, that give values at higher precisions, at higher accuracy than the meter rule, which we have said it can only give the reading, the length, up to 1 decimal place, whereby even this number is approximated to 8.5. So that's the measurement of length, and length is given, I have said length is a distance between 2 points. It is given in meters. And as I said, that although the SI unit of length is meters, we have other units. We have other units, multiples and multiples of length, that can be used for measuring length. And we choose the one to use depending on the length. So we have millimeters, we have centimeters, we have kilometers, we have even meter. although we are saying that the meters is the SI unit of measuring length, we have other multiples and some multiples of measuring length. And the choice of one depends on the magnitude or the size of what you're measuring. And as I said, it would be very unusual for me to say that the distance from here to let's say Mombasa, it is this number of centimeters. The distance from here to Mombasa is so long that I have to use maybe kilometers. It is 500 kilometers. So if I say that the distance from here to Mombasa is 500, I multiply by 1,000 to make the meters, then by 100 to make them centimeters, and even by 10 to make them centimeters. So it is 1, 2, 3, 1, 2, 3, and then I say that the distance from here to Mombasa is 500 millimeters. It doesn't sound quite right. So I'm saying that the choice of the unit to actually use, it depends on the distance that is there. Or I say that Tom here he's 4 meters tall. I have a boy here called Tom, or Alex, or even Liz. I have a girl here called Liz, who is actually 2 meters. That one could be right. But then, if I actually say that Liz is 2, I divide by 1,000, I say that that Liz is 2, Liz is 0.02 kilometers tall. Again, that one physically does not sound right. So we are saying that we have other unit for measuring length, but the choice of one depends with the size. So we have millimeters, centimeters, kilometer, meters, and many others. So, but we need to actually remind ourselves, how are they related? We know that 10 millimeters make 1 centimeter, and we have 100 centimeters is equals to 1 meter, and therefore 1,000 meters, is it meters now? Yes, 1,000 meters is equals to 1 kilometers. It's good. Those are the most common ones. I know there are others. There are others, but these are the most common. 10 millimeters make 1 centimeter. 100 centimeters is equals to 1 meter, and 1,000 meters is equals to 1 kilometers. It's good Form 1s at this level to know how to convert the unit of length. And let me just take one example before we proceed. Suppose we have 0.7 kilometers. You are told to convert to meters. How do you do that one? You say, first of all, you are told to change this into meters. It's good to write the link between these two units. You are converting kilometers and meters. We must ask ourselves, what is the link between these two units? So we write here 1,000 or 1 kilometer is equals to 1,000 meters. That is the relationship between the two. Then we ask ourselves, then what about now 0.7 kilometers? Itakuwa ngapi? How much will it be? Then from here, we simply cross multiply. So it is 0.7 kilometers. We multiply by 1,000, divided by 1. So we get it is 700 meters. So we have converted that already. Another example, suppose now we have 6,500, maybe another 0 there, 65,000 millimeters, you change into kilometers. There are various ways in which you can do this ones. You can first of all change in centimeters or into meters, or you can do it directly. So this ones, it has various levels. We have millimeters, and we are changing this all the way to kilometers. So how we do these ones? We first of all divide by millimeters. So we have 10 millimeters is equals to 1 centimeter. So it would be easier for us now, having that relationship, we need to divide now 65,000 millimeters. Because for every 10 millimeters, 1 centimeters, we see how many centimeters are this. We divide by 10. By dividing by 10, we're able to convert these ones now into centimeters. So that dies, we have what? 6,500 centimeters. Then we ask ourselves now, we are still moving on. How many centimeters make 1 meter? 100 centimeters is equals to 1 meter. So we divide this again by 100. But for every 100 centimeters, make 1 meter. So we divide by 100 there. We see how many meters are there. That's 0 and that one dies. So we have 65 meters. 65 meters. Now 65 meters now, we are now on the final step. We need to convert this one now into kilometers. So again, we ask ourselves, what is the link between these two? So 1,000 meters is equals to 1 kilometer. What about now 65 meters? It will be how much? We cross multiply, or rather we divide this by 1,000. We multiply by 1 divided by 1,000. We get 0.065 kilometers. So conversion of unit of length is really not a big challenge. And in case you have any challenge, student, there, you can send your questions or opinion to the number 2. You can send the number to 21126. In case you have any questions or any comments or any opinions or for any physics figure tips on all this, please don't hesitate to SMS us on 21126. When we meet next time, we are going to now proceed with other measurement of now the area, volume, and now the densities. But for now, we'll stop there. Thank you for paying attention. Nice time.